Friends, in part 1, we talked about the fluidics and we discussed about the different pump systems that drives Phaco machines. We also took special note of the peristaltic pumps. In that section, we talked about how flow being a function of the pump rotation and how vacuum rises in a peristaltic pump after the occlusion of the Phaco tip. We also talked about 3 basic principles of Phaco, and that any good Phaco machine has to satisfy these 3 basic principles. What are those 3 basic principles? Inflow should be more than outflow, or at least should be equal to the outflow. Second, less turbulence inside the eye, which can happen due to a mismatch between the inflow and the outflow. And third, the less heat buildup in the incision site so that the patient gets a clear cornea postoperatively. Having learned these principles in part 1 of the video, let us now look into other aspects of Phaco, that is, Phaco Energy. In this section, we learn the components of Phaco Energy, a little bit about tips and sleeves, and about allied subject matters. Hope you enjoy. Phaco power, or Phaco energy they also called, is largely a function of the stroke length and frequency of the handpiece. I repeat, the stroke length and frequency of the handpiece. Stroke length is the distance the Phaco tip travels inside the eye, and the frequency is the number of times the Phaco tip moves or vibrates. Think of how an woodcutter cuts the branch of the tree. Like in this picture, the distance that the cutter travels through the air to reach the wood is the stroke length in our phacoemulsification world. That distance of traveling through the air till it reaches the wood is basically our stroke length. The more the travel through the air, more the man gains force to hit and cut the log of wood. This is similar to stroke length of the Phaco tip inside the eye. The console of the Phaco machine sends electrical impulses to drive the Phaco tip inside the eye. The Phaco tip travels a certain distance to cut the nucleus piece. More the tip travels, more it gains force to break the nucleus. Hence, harder the cataract, more the force required, and hence more the stroke length that is required. In the left picture, the video, you are seeing the Phaco tip movement. Notice the forward and backward movement of the Phaco tip, which is what we call as the stroke length. So when you reach out to the power icon in the Phaco machine that you can see on the left and you are increasing the power, what you actually do is increase the stroke length. That is the distance the tip travels inside the eye. I repeat, when you go and reach out and increase the power of that machine that you can see on the side, on the right side, what you're doing is you are actually increasing the stroke length. So you decrease the power. If you want to decrease the power, you're actually decreasing the stroke length, and vice versa. So for harder cataracts, you may need more power, and hence you increase the power in the machine, in the machine display. In the display of the Phaco machine, power is displayed in percentage, and remember that the power is always displayed in percentage and not in absolute terms. That is, in this display, you are seeing 40% of the total stroke length is being used. If the tip can travel 90 microns at 100% of power, say for example company A, for the company A, the tip travels at 100% of power, 90 microns. Then here by setting a 40% of that of power, what you are doing, how much are you asking the tip to move? The tip is then actually moving 36 microns. That's because 40% of that 90 microns. At 100%, the 90 microns, the tip travels 90 microns for that company machine. So if you are choosing 40% of power, in this case, the tip will be having a stroke length of 36 microns inside the eye. So if two different makes of phaco machines are there, and in one Dr. A is using 40% of power and in the other Dr. B is using 50% of power, you cannot say that Dr. B is using more energy inside the eye, as the stroke length is displayed in percentage, and the two machines may have different stroke length in absolute terms. Hence, to make a comparison, you need to actually know what in absolute terms the stroke length of the two phaco machines are. Let us now look into the second aspect of phaco power, that is the frequency of the handpiece. Frequency in the world of phaco handpiece would mean how many times the phaco tip attached to the phaco handpiece moves back and forth. Frequency, I repeat, means how many times the tip is traveling back and forth, back and forth. Usually, handpieces would be around 40 kilohertz. 40 kilohertz means it will be vibrating around 40,000 times per second in the eye. It is important to note that though in a common language we say the ultrasonic handpiece, if you are there in the OR, someone will say, pass me the ultrasonic handpiece. What it means is that what goes into the eye is not an ultrasound. We don't send ultrasound inside the eye to break the nucleus. The ultrasonic handpiece here means that the phaco tip attached to the handpiece moves at ultrasonic speed, that is over 20,000 oscillations per second. Anything that moves over 20,000 oscillations per second, vibrates 20,000 oscillations per second, we mean it is ultrasonic. We call it ultrasonic because any object traveling at 20,000 per second, 20,000 times per second is moving at ultrasonic speeds. We can't see or hear it. So please also note here that the frequency of the phaco tip is fixed, unlike stroke length. Stroke length you can vary, but frequency of the handpiece is fixed and it comes from the manufacturer. You cannot increase or decrease the handpiece, frequency of the handpiece. So when you actually reach out again to the display and you increase the phaco power, what you are actually increasing is the stroke length and not the frequency of the handpiece, for the frequency of the handpiece is fixed. At this point, you may think, if increasing stroke length will help us to have more punch power inside the eye, why not always use highest of stroke length? We should always use highest of stroke length because that will break the nucleus, right? But that is not easy. Because remember, in phacoemulsification, we need to satisfy the three principles of phaco, and I covered that in part 1. Increasing the phaco power will cut the nucleus more, but it will severely raise the thermal or heat energy near the incision site, and also it can create turbulence. So that basically defeats phaco's second and third principle that I covered in part 1. Add to this, more the power used, more the chances of repulsion of the nucleus pieces from the phaco tip. As the repulsion or chattering of the nucleus pieces takes place, it takes a longer time for the surgeon to emulsify the pieces from the eye by building the fluidics back again, because if things are moving away from the phaco tip, you need to build the fluidics again, have more amount of aspiration, compensate with more amount of irrigation, and bring those nucleus pieces back again to that phaco tip, right? So that is why we cannot always increase the phaco power to its maximum limit. Certain crystals, such as quartz, are piezoelectric. That means that when they are compressed, they generate an electric charge. It works the other way as well as in a phaco machine. When you send an electric current through a piezoelectric crystal, the crystal changes shape slightly, and they starts actually, they generate impulses, particularly in phaco machines. A question that comes here is that how does the whole system to break the nucleus work? Here is how it works. The console of the phaco machine sends electrical impulses to a set of piezoelectric crystals within the handpiece. As the electric impulses drive the crystals contract and expand, the crystals contract and expand, electrical impulses are now converted to mechanical energy. The phaco tip that is attached to the crystals then start moving back and forth. It is this movement of the phaco tip back and forth that generates the stroke length inside the eye, which we commonly call as phaco power. The frequency, that is the number of times the tip would travel back and forth inside the eye, is however fixed, and remember that. So let us now talk of the phaco tip and the sleeves. And as the picture suggests, both tips and sleeves are an integral part of the phaco handpiece, without which the phaco handpiece cannot work. I mean, the phaco cannot happen. The phaco tip is firmly attached to the handpiece. Through a device called wrench, you firmly attach the phaco tip into the handpiece. And the sleeve, also called as irrigation sleeve, is attached to the tip. The flow of irrigation fluid happens through the gap between the sleeve and the tip. So the fluid that comes out inside into the eye, that irrigation fluid that flows from the bottle, travels through the irrigation tubing, through the irrigation line in the handpiece, goes into the eye through the gap between the irrigation sleeve and the tip, and there are two irrigation holes. The irrigation holes actually help the irrigation fluid to go through that irrigation hole inside the eye. So, in part 1, we have talked in detail about the need of the irrigation flow and how it balances the outflow from the eye, that is the aspiration flow from the eye. So if you want to revisit those concepts, you can go back to my video, part 1, Basics of Phacoemulsification. Now coming to the phaco tip, the breaking of the nucleus and the aspiration of the fluid and the nucleus material happens through the mouth of the tip, through the bevel of the tip, goes through the shaft into a special line built in the handpiece. We call the aspiration line in the handpiece, and then goes through the aspiration tubing, and then it collects into the drainage bag. The more the pump rotates, that is more the speed of the pump, again that is greater the aspiration flow rate, more the flow of fluid out of the eye. To balance it, irrigation flow through the irrigation sleeves is important, which is determined by the bottle height. Remember, we covered that in part 1. So higher the bottle of the height, more the irrigation pressure into the eye, and you will need more irrigation pressure into the eye when your aspiration flow is more from the eye. and aspiration flow is more from the eye when you set the aspiration flow rate, AFR, the pump speed at a higher rate. So irrigation has to be always balanced with aspiration. So irrigation has to be more than aspiration, or at least has to be at the same level that of the aspiration. Coming to the Phaco tip, and as you can see in the picture, tips are of different shapes and sizes. In this picture, you can see the difference in the bevel anatomy of the tip. The bevel means the opening of the tip or the mouth of the tip. Tip bevel or opening can be 0 degree or round shaped. It can be 15 degrees, 30 degrees or 45 degrees or 60 degrees. Even some companies manufacture 60-degree tips. More the degree of the bevel, or more we talk in terms of degree, that is more the degrees, 30 degrees, 45 degrees, greater is the size or the area diameter of that bevel. There's a 45-degree bevel of tip will have a greater opening or surface area of opening than the 30-degree. Or the 30-degree bevel tip would be bigger in size. Its surface area of opening of the bevel would be more than the 15-degree, and the 15-degree would be more than the 0-degree. This is important to note, as this geometrical shape is important in determining 3 things in a peristaltic pump. How fast the tip is covered by the nucleus material, that is, how fast occlusion is reached, how fast the vacuum will build once the tip is occluded, and the cutting power of the tip. Lower the opening of the bevel of the tip, that is the 0-degree bevel tip, will have a smaller mouth and hence faster or easier to occlude. However, though it is easier to occlude, the holding force that it would generate would be less than that of a higher degree tip, that is a tip which has a greater surface area of bevel. Hence, a 0-degree tip is easier to occlude but will generate less holding force than a 30-degree tip or a 45-degree tip. I repeat, a 0-degree tip is easier to occlude, easier to block the tip with nucleus material, but will generate less holding force than a 30-degree or a 45-degree tip. Therefore, if you are working on a 0-degree or a 15-degree tip, you may have to raise your vacuum limit in the machine to higher levels to help you have an adequate holding force. We can take a simple example. Think of a child, of 10-year child and an adult. If the 10-year child is sucking up a glass, an empty glass on his mouth, he's just holding that empty glass on his mouth by sucking it, and an adult also doing that, who will have a greater holding force? The adult, because his mouth opening is bigger, will have a greater holding force, and the child, to compensate that, because his mouth is mouth opening is lower, to compensate that, he needs to suck harder. So in terms of cutting ability, if we talk of cutting ability now, so we have to understand how this degrees of bevel, that is the surface area of the bevel, has an impact on the cutting ability. Between 0 degrees and a higher degree tip, say for example 45-degree tip, 45-degree tip will be difficult to occlude, but will have a greater holding force once the tip is occluded, and will cut more or break the nucleus more than a 0-degree tip with the same amount of energy spent in the eye. So the choice of the tip remains with the surgeon, however, and the grade of the cataract. Remember that when you have a 0-degree tip or a round shaped tip, the surface area is small, easier to occlude. However, it needs more amount of holding force. I mean, you need to raise the vacuum more to have the similar amount of holding compared to a 45-degree tip. And because the surface area of the bevel is less, the cutting action will be poorer than that of a 45-degree tip. Here is a table that will help you to understand how the bevel angle actually determines the occlusion, vacuum or holding force, and the cutting ability. Remember, we talked about phaco power largely comprises of stroke length and frequency of the handpiece. While we cannot increase the frequency of the handpiece, we increase or decrease the stroke length, that is how far the tip is traveling inside the eye according to the grade of the cataract. Now the choice of the bevel of the tip, that is if a surgeon works with 45-degree tip, adds to the cutting action or ability of the tip. This is because the 45-degree tip will have a sharper edge and hence its penetration ability into the nucleus would be more compared to a lower bevel tip. So let us put it all together now. And in this picture, you see the surgeon is in foot-switch position 0. There is action now. There's no action now actually, and the phaco machine is in a resting state. There is no irrigation, and hence there is no aspiration or flow, and there is no power. Vacuum is not generated. As the surgeon goes into foot switch position 1, irrigation solenoid opens up and there is irrigation pressure inside the eye. There is still no flow as there is no aspiration happening. Hence, there is just the irrigation pressure. There is still no vacuum generated inside the tip or tubing as there is no occlusion. That is, the phaco tip is not occluded. As the surgeon goes into foot switch position 2, the pump of the peristaltic machine starts rolling and drawing fluid from the eye. With how much speed the pump starts to rotate will depend on. So now that the vacuum has reached its preset levels and you have got a good grip on the nucleus piece that has occluded or blocked the phaco tip, this is the time to go to the foot switch position 3 and add power to break the nucleus. As you break the nucleus piece, the vacuum now drops because the fluid and the nucleus piece is being drawn and emulsified through the tip and the aspiration tubing through the aspiration tubing into the drainage bag. 2 of the basics of Phaco, and in part 3 of basics of Phaco we will cover the different energy modalities, that is the continuous power, the pulse, the pulse, and how it works. You may also follow my blog quickguide.org for more informations. Do not forget to subscribe to this channel as well as subscribe to my website quickguide.org. I have recently launched a biometry validation tool wherein you can validate the biometry data that you generate for premium intraocular lenses, all available at quickguide.org. See you. Thank you for listening.